Now I am using PWM using Flowcode. First open Flowcode and create new flowchart and take 16887 IC and configure it at 4 MHz clock and internal oscillator as a clock pulse and RE3 pin as digital input output pin. Okay, now draw the flowchart. PWM means on and off. I am control the on and off pin by analog read. I am take a input as analog read and change it is knob to a slide bar. I am taking a slide bar, increasing the size of the slide bar and take the second style of the slide bar. It is the analog read and it is connected at analog read A0 pin. There is a A0 to A13 14 analog input pin in PIC 16F887. Okay. Now PWM means on and off, a single pin. So I am taking a LED as a output. To on and off the LED means a PWM. I am take the LED in port D0 pin. Okay. Now draw the flowchart. First infinite loop is here. Now take a component macro. First analog read. It is read as a byte value and it is stored in a variable. I am take a variable as a name as ADC. It is the initial value is 0. It is analog read. I am taking a description as analog read. Okay. When I am changing the value, it is stored in the ADC. Now I am taking a component macro to on the LED. After on it, I am taking a delay and delay time is the value of the ADC. I am taking the value of delay as the ADC millisecond. The value of the ADC is, if the value of the ADC is 240, it is 240 millisecond. After that, taking the LED as off, and after that a delay, and it is delay of ADC millisecond. If the ADC is 30, then the value of the delay is 30 millisecond. Okay, now run it. When I run it, you can see the LED is on and off continuously. When I increase the slider, you can see the on and off speed is slowly. It means on time and off time is increasing, means duty cycle is increased. Now I am save it. After saving this flow code, I am compile it to a hex file. I am using the name is PWM using Flowcode. Okay. Now compile to hex. Wait, still it is finished. Okay, now finish it. Now open Proteus. I am taking IC 16F887 to read the analog. I am taking pot. It is potentiometer. Okay. Now place the IC and place the pot. Here port is connected as A0 pin, means pin number 2. It is AN0, analog read 0 number pin, and ground and VCC is connected to the potentiometer. Okay, and take a oscilloscope to the output of the IC. It is D0 pin, it is 19 number pin, and connect a oscilloscope at 19 number pin. Now the program files I am pasted here, and frequency is 4 MHz. The hex file where I am save it, here is the hex file is here. Now take the hex file to the Proteus. Okay. Now run it. When I am run it, you can see in CRO it is on and off, on and off. When I change the potentiometer value, you can see the on and off time is changing, means duty cycle is decreased. When I increase the potentiometer value, you can see the duty cycle is increasing. To perform a PWM like this in a PIC microcontroller, it is a very simple method to perform a PWM. Now I am taking another way to draw a PWM. PIC microcontroller has inbuilt PWM control. I am using this inbuilt PWM control. Now whole thing is deleted first, and delete the LED also, and remove the slider also. I am taking inbuilt PWM. Go to Megatronics and select PWM, and it is PWM selected at CCP1, means PWM 1. You can see the CCP1, CCP2, CCP3 in PIC microcontroller. Here is CCP1 is 17 number pin. Here is CCP2, CCP3, many of them in PIC microcontroller IC. I'm connected at CCP1. Now taking a component macro first. First enable this PWM. After that taking an infinity loop. In infinity loop I am set the duty cycle of the PWM. It is 0 to 255. In between them I am taking a value as 47. Okay. Now run it and see here is a PWM, and the duty cycle of the PWM is 18%. Now compile it and see in Proteus this PWM. I'm got put a value of a duty cycle, and PWM is output, PWM is occur. Now go to Proteus, connected at CCP1. CCP1 pin is 17 number pin. It is connected to the CRO. When I run it, you can see the PWM here. Here is the PWM output. The off time is greater than the on time. And delete the potentiometer. There is no need to potentiometer. This off time is greater than the on time. If I change the value of the duty cycle, now I am change the value of the duty cycle 47 to 105. Now see the duty duty cycle is 41%. The on time is increasing. And compile it. Now go to in Proteus and run it. You can see the on time is increased. And this PWM very much smooth than the manually PWM. Now I am taking a ADC to control this PWM. First I am taking the slider. Knob is not needed. I am taking slider. Knob is very difficult for this. Okay, no. First, it is read at ADC. Variable is created by first. The value of the ADC at put in the duty cycle. When I change the analog value, the duty cycle is changing. When I change the knob, the duty cycle is changing. Here you can show this. Change the value of the knob means change the value of the analog input, the duty cycle is change, means on time and off time is change. Now compile it and after that go to the Proteus. When I am going to the Proteus, first I am connect the knob. The knob is default connected at AN0 pin, means analog 0 input pin. Okay, compile is done. And it is connection at AN0 pin. Going to Proteus, connect potentiometer at AN0 pin. VCC and ground is connected to the potentiometer. Now run it. When I run it and change the value of the potentiometer, you can see the PWM value is changing. And change the potentiometer and the PWM value is changing. To use PWM, we can control the DC motor speed. Now I am trying to connect a DC motor to the output. I am control the motor speed. Here simple DC motor is taking. To drive the DC motor we need L293D IC and a battery to power supply it. Okay, now delete the oscilloscope. First take the L293D IC. I am taking first L293D IC, first edge bridge of L293D IC. And VCC is connected and ground is also connected to the IC. There is two input pin. One input pin I am connected to the ground. Input 2. First H bridge input 2 is connected to the ground and a power supply, the battery is connected to the L293D IC. VCC and ground is connected to the positive and negative respectively. And input 1 is connected to the PWM output of the IC. To the output I am connect a DC motor. I am taking the properties of the DC motor. It is 12 volt DC motor, and taking a revolution or RPM is 60 RPM. Now I am run the circuit. When I run the circuit, see, motor is rotating. Now I am decrease the analog value. When I decrease the analog value, you can see the speed of the motor is slow. When I decrease the minimum position, the motor is stop. When I increase the analog value, the speed of the motor is increasing. When it is in full, the motor speed is highest. The motor is very speedy, rotating. When I decrease, the motor speed is decreased continuously. I am continuously decrease the potentiometer value, the motor speed is decreasing. Now I am connect another DC motor to the L293D IC at second H bridge. First enable it connected to the VCC, and IN3 is connected to the PWM, and IN4 is connected to the ground. You can see one motor is moving, another motor is slow down. Why? Because of the second motor RPM is not set to at 60 RPM. I am set it is 60 RPM. Two motor is set to 60 RPM. When I am run it, you can see the two motor run at same direction and same speed. When I am control the input, you can see the speed of the motor is increasing. When I decrease the input, you can see the speed of the motor are decreased. Now I am change the connection. Now there is two motor. I am changing the connection. In second motor, I am connect input 3 is ground and input 4 is in PWM connected. Now I am run it. You can see the two motor run at same speed but in opposite direction. When I am increase the analog value, two motor run in high speed and it is in opposite direction, but it is running in same speed. When I decrease the analog value, two motor running at same speed at slow and it is run in opposite direction. Now I am change the input of second H bridge. IN3 is connected to the PWM and IN4 is connected to the VCC. Now what happened? The second motor is run at high speed but first motor is run it slow, but in same direction, sorry, opposite direction. When I increase it, you can see the direction is opposite. When I increase the potentiometer value, first motor is run in high speed, but second motor run in slow, but it in opposite direction. And decrease second motor in high speed and first motor in slow. Now I'm change the connection now. I'm connect IN3 as a VCC and IN4 to the PWM. When I'm run it, two motor are in rotate in same direction, but in different speed. When I increase the potentiometer value, first motor is run its more speed, and when I decrease the potentiometer value, second motor run in more speed, but the direction is same.